DC-DC step-down converters, also known as buck converters, are circuits that convert a higher input DC voltage, e.g. 12.8 volts, to a lower output DC voltage, e.g. 5 volts. These converters are highly efficient as they operate with minimal energy loss during voltage conversion. Unlike linear voltage regulators that dissipate a significant amount of energy as heat. How does a DC-DC step-down converter work? The operation principle is based on switching. The converter uses a transistor that switches on and off rapidly to control the flow of energy between the input and output. This creates a pulsed DC voltage. An inductor and a capacitor are then used to smooth this pulse voltage to produce a steady DC output. Main components of the circuit: transistor switch, the primary active component that switches on and off rapidly to control energy flow from input to output. MOSFETs are commonly used because they offer fast switching capabilities with low losses. Diode provides a path for current when the transistor is off, known as the freewheeling diode. It helps maintain the circuit's energy supply. Inductor smooths the current and stores energy received during the transistor's on and off states. It helps stabilize the output voltage. Capacitor filters out residual ripples caused by the inductor, ensuring a smooth DC voltage at the output. Control circuit regulates the transistor's switching speed and pulse width, known as PWM, pulse width modulation. The controller senses the output voltage and adjusts the switching cycle to maintain the desired 5-volt output. Step-by-step operation process. Switching. The control circuit turns on the transistor, allowing part of the input voltage to pass through the inductor. Energy storage. The inductor starts storing energy in the form of a magnetic field. Switching off. The control circuit turns off the transistor. The energy stored in the inductor flows towards the diode and reaches the output, maintaining continuous voltage. Smoothing. The output capacitor reduces any voltage fluctuations, resulting in a stable 5-volt output. Example application: in cars, there is often a 12-volt battery, but various devices, such as USB chargers, require only 5 volts. A step-down converter can efficiently convert the car battery's voltage to 5 volts, which is suitable for operating USB devices. Summary: step-down converters provide an efficient and reliable way to step down voltage with minimal energy loss. The cooperation of the basic components, transistor, diode, inductor, and capacitor, allows the circuit to convert input voltage into a stable output voltage, making it ideal for powering various electronic devices. If you're still here and enjoyed the video, please give it a like. If you'd like to see similar content, subscribe so you don't miss out on anything. If you'd like to support my work, you can do so by clicking the link in the description. Thank you for being here, and see you next time.